All right, these are your 8-2 notes multiplying a polynomial by a monomial. And so we are going to utilize the distributive property to do this. And we're also going to use properties that we learned back in Chapter 7, when you multiply exponents together, how you add their exponents. So a little different from yesterday when we were adding and subtracting, we left the exponents alone. Now that we're multiplying, there's going to be times where you need to change the actual degree of the exponents because you're multiplying, so you add exponents. But then also there's going to be times where we're combining like terms, and so then you leave the exponents alone. So it's going to be a little tricky. Slow down. Haste makes waste, and if you take your time, you should be pretty successful with this. It builds off of an old concept, the distributive property and power properties. The distributive property is taking a quantity on the outside of parentheses and multiplying it, distributing it to every term inside the parentheses. The only difference is we really haven't seen or used the distributive property with variables on the outside and variables on the inside. So anytime we used a distributive property, it was usually a number on the outside and maybe one variable on the inside. So a little bit more complicated distributive property. So you're going to distribute the monomial that's sitting outside of the polynomial. And then if you can, not always, but if you can, you're going to combine like terms. Remember, the same variables to the same degrees. So let's go ahead and try this. Number 1, we've got a 6y on the outside. That's your monomial. And then we've got a trinomial, 4y squared minus 9y minus 7. So I'm just going to go very slowly because there's a lot going on here, and so we want to make sure that we don't make any mistakes. So the first thing I ask myself, I don't look at that as 6 and 4. I look at that as a positive times a positive makes a positive. I take the time to get an energy to give the signs the same respect at the same time as I do the numbers and the variables. So positive times positive makes positive. 6 times 4 makes 24. And y times y squared becomes y cubed. That's that rule that when you're multiplying, you add the exponents. So this y has an exponent of 1. This one, y squared, has an exponent of 2. We add the exponents. And now I'm going to take that 6y. I'm going to extend my arrow to this negative 9y. It's not a 9y. It assumes the sign in front of it. So a positive times a negative is a negative. A 6 times a 9 is 54. And a y times a y makes y squared. And so we're done with the second term. And the third multiplication is taking the 6y and multiplying it by the negative 7. So a positive times a negative makes a negative. A 6 times a 7 makes a 42. And since there are no other y's here, the y just kind of hangs out and goes along. You don't get rid of the y. There was a y with the 6, so it's part of the answer. There just wasn't anything to combine it with, like the 7. We look real quick. I see a bunch of y's, but this one's y cubed. The second term is y squared, and the third term is y. So I can't combine any of them together. This is your simplified product. We look at number 2. There's 2 different things we have to distribute. I first have to distribute the 3 through, and then there's another whole distribution going on where you're going to take the 6t through the second set of parentheses. So same thing. Each time I'm going to multiply, I'm going to just draw an arrow. Positive times positive is positive. 3 times 2 is 6. And there are no other variables out here, so the t squared just stays with it. Okay, you can't get rid of it. It's still there. It just didn't increase. There wasn't any more t's to add to it. Next term, positive times negative makes a negative. 3 times 4 is 12. And there are no variables on the outside, so the t remains t. Next term, positive times negative is negative. 3 times 15 is 45, so it ended up being a negative 45. Continuing on to the next monomial and polynomial, positive, because of this plus sign, that's a positive 6t. So if it was a negative, I would distribute the negative through. It's a positive times a positive makes a positive. 6 times 5 makes 30. T times t makes t squared. And then a positive times a positive makes a positive. A 6 times a 2 makes 12. And there's still the t from the 6t. I do a quick scan of the entire problem, and I see a 6t squared here, and I see another positive 30t squared here. So I'm going to add those two together to make 36t squared. I see a negative 12t here and a positive 12t here. They actually cancel each other out. A positive 12 and a negative 12 turn into 0, so I don't even have to write. The t's just go away. And then we're left with a negative 45. So that was where we had to actually do a little bit more work after we distributed. We had to clean up by combining like terms. Proper form is that standard form. It wouldn't be wrong if you had this in a different form, but try to write them so that they go from greatest degree down to the least degree. That's pretty much the basics of the lesson. The only other thing we're going to do is we're going to solve for the variable in which you have to distribute. So we did this way back in chapter 3, but again, we didn't have variables on the outside that we were distributing. So when it says solve, we got to find the actual number for the b value. What b value, what number do we plug in for b that will make this statement true? Okay, take your time. It's pretty complicated. It's easy to make a mistake. So the first thing I'm going to do is distribute. I have a positive times a positive makes positive. This is really a 1b, so a 1 times 12 makes 12. And then there's no other b's, so it just stays b. I have 12 b's there. Distribute positive times positive makes a positive. A 1 times a 1 makes a 1. You don't have to write down the 1, but you're more than welcome to. And then b times b makes b squared. This minus 7 does not get multiplied by b because it's not inside the parentheses. So that just gets included in the equation. Equals, same thing here. This 2b is just sitting on the outside. It's not going to get multiplied, but you can't forget about it. And now we're going to take this positive b here and distribute it through the second set of parentheses. So a positive times a negative makes a negative. A 1 times a negative 4 makes it the negative 4. That is the negative part. And then there's a b. And a positive times a positive makes a positive. And a 1b times a 1b, well, the 1 times 1 makes 1. And the b times b makes b squared. So looking at our equation, we got a bunch of junk. Now, I'm going to look at this just one side and the other. So I'm going to draw on here and show you what I'm concentrating on. I'm only looking at this part, the left side of the equation. Don't worry about the right-hand side. Is there anything we could do to clean that up? I can't combine like terms. The only thing I could do is maybe write it in a different order, but we're not going to leave our answer this way, so I think it's just fine. If there was a b with another b that we could put together, we would, or a b squared with another b squared, we'd put that together. Looking at the right side of the equation now, I see that there's a 2b and a negative 4b. So I should probably clean this up before I try to solve for b. So in this step, it's been a long time since we solved equations. In this step, I'm not moving things from the left side to the right side. I'm not using inverse operations. I'm cleaning up the sides individually. Since the left-hand side doesn't need any cleanup, I am just going to rewrite it. And on the right-hand side now, when I put a 2b and a negative 4b together, that leaves me with negative 2b plus a b squared. I just got rid of my 1b's. So now both sides are cleaned up. I need to get the b's to one side and the numbers to the other. Well, if you subtract a b squared, we have not solved when things are squared yet. So most of the time, if you get a b squared, they should cancel. So this positive b squared and this negative b squared, I decided to subtract b squared from both sides. I used the inverse operation. It cancels here. So I'm left with 12b minus 7. And then what it equals The b squared minus b squared cancels on the right-hand side, so all that we're left with is the negative 2b. We're getting closer. Okay, I have b's on both sides, and I have a number, that negative 7. So the goal is to get the 7 by itself and get the b's together. So since 12b is with the negative 7, I'm actually going to subtract 12b from both sides. Inverse operations, anytime you want a term to move from one side of the equation to the other. So I want my b's to show up on the right-hand side, so I use inverse operations. This is a positive 12b, so I'm going to do the opposite, subtract 12b. What that does is it cancels it here. We bring down our negative 7, and it shows up over here on the right-hand side with the negative 2b. And so what we end up with is negative 14b. Almost done. Negative 14 times b is really what that is. So to undo the multiplication and get b all by itself, I need to divide by negative 14, divide by negative 14, and negative 14 divided by negative 14 becomes a positive 1, or b, and negative 7 divided by negative 14 is a positive 1/2, and that's your final answer. So when you solve, you'll actually get a number for an answer. When we simplify or multiply, you'll probably have variables in your answer. Okay, so what I'd like you to do is name the property used, what is the old property that we're revisiting, and I'd like you to solve this problem here. Okay, a little complicated. You got 2 distributions to do. Be careful of your signs. Take care. Show all your work so I can figure out if you are making a mistake, I can help you. That's the kind of conversations we need to be having. Good luck.